So the topic today is really about a tool. It's called Test Kitchen, and Chef maintained the tool. It's a open source project, and I work for Chef as a lead sales engineer in APJ. I'm based here in Singapore. I've been living here for some time now, and call it home. Just a little bit about Chef. We are really known in the infrastructure as automation company. Our product is also called Chef, right? Our Chef Infra, the new name to differentiate from other products that we have, such as for compliance and for application automation. So the underlying theme for the Test Kitchen is we want to be able to understand that, to use it. The theme is really a lot of organizations nowadays, they always come back to us and wonder, like, is there a faster way? Is there a better way to create before they go to production? They want to be able to kind of create an environment where they can replicate, not only spin up a machine for the test environment, whether that's SIT, UAT, any pre-production, but they want to be able to configure these machines and do some testing to it, right? So there are many ways to do that. Obviously, the virtual machine is one way to do it, but you still need to do some kind of configurations to this machine. And furthermore, once you configure that to look like your pre-production, you still need to do some kind of testing. So basically, that's what the Test Kitchen is actually for. Really to speed up your kind of development process and have the tooling to not only provision, but to configure the machine as well as testing it. And we'll go through that motion. It will be a lot clearer as we go through the exercises. We'll have three simple exercises to do today, and it should occupy about 40 minutes to an hour. We'll talk about, after those, we'll talk about some other use cases or patterns that we see with the Test Kitchen. Now, in terms of what is Test Kitchen actually, this is basically the definition. Test Kitchen is a test harness tool to execute your configured code on one or more platforms in isolation. So that means a lot. You don't need to understand everything now. It will be a lot clearer, hopefully, when we finish all these exercises at the end of this session. But the key here is that the big use case of the Test Kitchen is going to be in the pre-production environment, right? In your SIT, in your development, UAT, everything before you move into the production. So the Test Kitchen is basically some of the design philosophy is to it needs to be simple. And one of the things that the Test Kitchen takes as an input is a YAML file. It's basically a declarative, static kind of configuration where you specify the kind of things that you need, for Test Kitchen, for the environments to execute and to be configured and later on to be tested. So here's an example of so basically it takes a file, and it's usually by default is called kitchen.yaml. And in that file, there are several things in there you can configure. First of all, you can configure the drivers. The drivers basically just simply means, the underlying or the one that's provisioning your server. So what that means is if you are on your laptop and somebody who used Vagrant before, you can use Vagrant driver. If you like Docker, which is very, very popular, you can spin up Docker instances, right? If you're in public cloud, you use EC2. You can also use Test Kitchen to spin up the instances to provision your servers. And you know, the kitchen will basically will talk through the underlying driver to do the configurations necessary in order to create your machine. So the first thing is it will spin up a virtual instance for you through these drivers. That's what Kitchen does. How many of you have used configuration management tool? Just show a code. You have? What kind of configuration management? Chef. You use Chef? Okay, great. And any other? Puppet? Okay, great. So just to let you know, the kitchen is actually can be used with Puppet. It doesn't have to be in conjunction. Yep, Ansible. There you go. That's quite popular. So kitchen can be used also with Ansible. So yeah. So you can specify. We call that provisioner in kitchen language. Basically, you know, what configuration management that you want to use in order to, you know, once you provision that machines, you know, how you want to, you know, what kind of software, what kind of configuration, what's other software that you want to interact with in making sure this machine end up to the state that you want it. So in our case, it's a Chef 0 for the to utilize a Chef-owned software configuration management. I bet you can also, for those who doesn't use configuration management, you can also, I think some people are more familiar with like shell scripts, right? You can plug in your shell scripts also underneath this kitchen. What are the supported? There are quite a few of them. So I know Puppet, Chef, Ansible. I'm not sure about Salt, whether that's, you know, whether it's supported. I wouldn't say supported, but available. The thing about this is anybody can kind of like create a plugin to interface with Kitchen. So drivers, provisioner, verifier, everything that we're going to talk about today are available through plugins. So anybody, and this is an open source project, so if nothing is available for you, or you have some configuration management software that you have in mind, you can create a driver for this, or a plugin to interact with Kitchen. Yeah? The next section in the YAML file is one thing what we call a verifier. It's basically the software that we execute to kind of test your configuration automatically, right? And this is, again, this is an optional piece of it where you can actually do it manually, but that's going to take a long time. Or you can use some kind of automated tool out there that would basically go into your systems and do some kind of verifications for you. So this is where you can say like, okay, that machine is set up correctly, created correctly, and I've tested everything in there, and looks like it's good to go. Platforms is kind of obvious. Those are the different operating systems that you can specify. So here we have an example of Ubuntu and CentOS. You can create a number of platforms or specify a number of platforms that are in the kitchen.yaml. I'm sorry?
The platform, is it the name of a providing image or just to tell kitchen the operating system?
So the platforms is here indicate the name of the OS, but actually also can be an image. For example, if you use Vagrant, it will know where to get it. If you are, let's say, on EC2, then you probably need to give it additional information, like a AMI ID. So this will be just kind of like a placeholder for you, like a, like a tag or something, to indicate the kind of OS that you want to spin up. Okay. So yeah, with each of these, there are further information that you can specify, like the image, the AMI ID, or where to get that OS. It'll be a little bit more clear when we look into the actual kitchen.yaml that's going to be in your instances. And the most interesting thing is this thing called suites. So suites basically specify a scenario, right? The scenario that you want to automate. This is your configuration, really. In this case, I have a scenario that I call web server. And in order to execute that scenario, I'm going to rely on my provisioner, which is Chef. And in the Chef lingo, we're applying a cookbook. So the scenario here is basically a web server where I supply a cookbook called Nginx. And that cookbook will do the automation, will do the installation and configurations of a web site for me, right? And obviously in the kitchen YAML, you can specify any number of scenarios. And this is what makes it kind of like powerful, the combination of scenarios and platforms, right? And that's what we call a matrix. So this is just, basically this is a Chef notation. Apply a cookbook for web server scenario, for web server suite. But moving on to that, the test matrix is the one that kind of gives it a lot more power to the test kitchen. So think about it. You have a number of platforms that you can create, a number of OSs. We saw in this example, we saw 2 of them. And you can also specify a number of suites. So the matrix is really the multiplication of the scenario and the platforms, right? If you have, for example, 3 platforms you want to create, and then you have 3 scenarios, such as you want to install a server, you want to install a client library, and then you want to install some kind of backend. Then really, the marriage of these platforms and scenarios is the one that create the matrix, and you have all the possible combinations that you can automate with the test kitchen. So that's what it's going to look like. In our example, we have one scenario, which is just a simple installation of web server on 2 platforms. So 1 times 2 is 2. Therefore, that, what this kitchen is going to do for you is create a web server on Ubuntu and create a web server on CentOS. And then for each of this instance, it will verify that. Any questions? Okay. Let me, I think I forgot one thing. Sorry.
So is there a way to specify? So if you, right now in this case you have done one Ubuntu server, web server,
Yeah.
and one CentOS web server. Right? So
Yeah.
what if you want to do like multiple CentOS servers, maybe like 3 CentOS servers?
Oh, okay, good questions. So the question is like, here we have 2 OS scenarios, I mean 2 platforms and 1 scenario. But what if I really have 1 platform and I want to kind of repeat that, right? Same thing, you can go back to the, you still have 1 suite, and the platform, you can repeat as many as you want. You can create a different name for it, right? You can say Ubuntu 6.1 or Ubuntu 6.2, but they will actually refer to the same image maybe, or it could be slightly different image, slightly different versions, maybe different revisions, minor number. That's okay. You can do that in the kitchen, or vice versa. You can have 1 platform and multiple scenarios. Right? Is it good? Am I recording correctly now? I think so. Thank you. Okay. Any other questions? Okay, so so the test kitchen has kind of like a cycle, like a workflow. It's a very simple workflow. And the workflow is like, obviously you need to start with some, from scratch. You need to start fresh, and you will create an image. Create a virtual machine. After that, you need to apply your configuration. In this case, because it's Chef, we are using cookbooks. We'll install all the tooling necessary. We'll copy the cookbooks and apply that to run the scenario. And then we'll verify whether those configurations run properly. And then after everything is good, we just destroy that. And then we repeat the cycle, right? This is how things are done in the pre-production environment. You always want to start with a fresh machine so that you can you can find out like the dependencies that you kind of carry with with your own configuration. So you want to be able to separate those. And this cycle is really matched with what the kitchen commands. So kitchen has many subcommands, and to start with, you would call kitchen create, which is going to create a virtual machine for you. That's it, nothing else. You can stop there. It will have a VM up and running. If you go on to the next one, which is kitchen converge, then it will take that existing virtual machine you created using kitchen create, and it will apply the configuration management. Okay? And if you have an automated testing, then you can apply kitchen verify, and we'll run that and give you the outputs, whether you pass the test or you fail them. And kitchen destroy will destroy everything, and then you start again from scratch. So that's the basic life cycle, a simple workflow, which is what the kitchen is really intended for. We want to use declarative language again to make it static configuration, to make everything simple. And we favor the freshness of your code, of your environment, to eliminate unnecessary dependencies or any gotchas that you will find normally with kind of like old servers, old machines. Okay, because usually sometimes things are already configured for you. Questions so far? Yeah. Yeah, so the buzzer is just basically the old name for verifier. Yeah. So it's it's actually the same as verifier. There was an old kitchen, and this is they call it a buzzer before. Yeah.
These slides we shared later on.
Yeah, we can put it up and. Yeah. Also, yeah, they are recording it so that they can put it up on their website and anybody can watch it later on. Okay? Any more questions? Clear? Okay. Just curious, since you work in, I assume, corporations, big or medium or small, how long does it take in general for you to do this kind of thing? Anybody want to give me a little bit of input? How long does it take for you when somebody asks, I need to test my, test ABC application? And then you need to find a machine or create a virtual machine, do all the installations, do the checking. How long does it take? A week? Okay. That's about that, right? Any other input? 4 minutes. Okay, how did you do that? Oh, 4 months, sorry. I was like, 4 minutes, that was like the fastest. Well, 4 months is long, but I don't know, it's like, I'm not surprised. There are organizations who take, I've seen between what I've seen in some banks or big complex, a little bit complex organizations, 2 to 4 weeks. Yeah. And it does take a while to get everything configured, tested properly. And that's relatively fast, I think, 2 weeks. So this is really the, I think, to answer some the gentleman's questions before. What are the what are other toolings that are that play well with Test Kitchen, that are supported by Test Kitchen? So again, the driver, there are numerous of them. You can use Docker, Vagrant, EC2, any public cloud. Azure is actually, Kitchen is integrated. A lot of our toolings integrated pretty well to Azure. In terms of provisioner, Ansible, Puppet, us, shell scripts, Bash, numerous platforms I cannot think of. Basically Linux and Windows, different platforms, different OSs. And the suites is just basically capabilities within the provisioner, right? So let's begin our, we need to do typey. Let's log into your workstation. And let's take a look at the actual kitchen that we're going to use, the kitchen YAML file. So you should see something like this. There are two things that are important on this workstation. One is the visual code. You're going to use this editor to do modifications to Kitchen YAML and maybe other files. And the second one is the basically a command line or command. What does that call it? PowerShell in Windows. Yeah. So these two things that you need really. Or maybe a third thing later that we're going to use is a browser to verify something, but pretty much we're going to use the command line and the Visual Studio. Yeah. So the command line is available here. You click that, or at the bottom. The Visual Studio, you can, let me just close this and show you. You can also type code. When you type code, it will launch a Visual Studio Code. Okay? But the first thing I want you to do is to go to my repo and download this Cookbook, this web server that has a kitchen YAML. So in order to do that, let me show my screen. I think you started in the user chef. If not, you can go to this user chef cookbooks directory. Yeah. Make sure you are in there. And do a git clone. That's the URL. github.com tb-training web server. For me, it's going to fail because I already downloaded it, but for you, you should have it should download, and you should see a structure like this inside that web server. Yeah? Good? All right. I think I might have, if I confuse some people because they're different speed, again, go to, make sure you're on the cookbooks of the user chef directory, and then do a git clone. That one. That's it for now. Let me just switch. I think I have, how about this one? You should see something like this. Yeah? Okay? Everybody got it? Show of hand? Good? All right, good. Okay, so you're getting the web server artifact. And if you look into what's inside it, there's basically a bunch of directories. We don't care what's inside, but we only care that there's, for now, that there's kitchen.yaml. Yeah? And if you don't have the Visual Code open, you can issue this command. Okay? Let me go back here and so you should have something like this. A Visual Code with the web server, directory opened, and a bunch of files and directories underneath that. And what we are really interested in is modifying this kitchen YAML file. This is what we talked about before, right? The kitchen YAML is, it has the driver. We said that the driver is responsible for creating your virtual machines. So we are on the EC2. it will interact with the EC2 and create your instance.
Kitchen YAML file is in the web server folder.
Yes, there should be a kitchen YAML in the web server. Yes? Okay.
So this will create a EC2 instance.
Yes.
So you actually have the credentials outside the environment.
That's right. And that credentials is there, also specified. So here, when I'm creating it, I'm using that PEM key.
I mean, this actually like AWS CLI command that it needs to.
Exactly.
Do you need to you need to run AWS space configure to put in the.
No. So the kitchen YAML knows how to interact with the EC2 through API. So there's no need for you to do command line. But what you do need is you specify that your drivers is EC2, and you need to specify how, you need to tell kitchen where to create their instance. So for example, the region, the security group, the subnet, and what credentials that you need, you supply that in this kitchen.yaml. Yeah?
Like, how do you specify like the secret key or access key or like the profile, the AWS profile?
This is it. This is your secret key.
So it's not SSH key. Like to spin up, to use AWS CLI, you need to do AWS space configure to put
Yes.
in the.
You can use that also, the same thing. Yeah. That is actually,
And password.
yeah, you can use that.
But in China, this is SSH key ID is different.
Okay, I think I know what you're talking about. The so I believe it's in the. Okay, so this one also you can do it through a role also. So this workstation has a role, and that role has the ability to create instance. That's one thing. Yeah? You already log in, by the way, you are already inside the EC2 here. So you don't need to do that that username password anymore. You're already inside the EC2. All you need is appropriate role in order to be able to create the instance.
Appropriate IAM rules.
Exactly. Yeah.
Don't use SSH key.
And in that instance, you can go into using this SSH key. Yeah. Okay. All right. So before I forgot, one thing I want you to do before doing any kitchen related command is change this section, your name, to your whatever name that you want. It can be your login name, your nickname, your first name, last name. Yeah? And then save it. And save is Control S. The reason is we are going to create an instance very soon. And I want to be able to track if I need to troubleshoot anything. Yeah? Everybody did that? Go ahead.
How does Kitchen like bootstrap the node like with Chef client? So it's Kitchen that does that, right? Like
Yes.
installs,
Kitchen will do bootstrapping as well in terms of, you're talking about Chef client, Chef bootstrap.
Yeah, yeah.
Okay. So the question is, how does Kitchen actually configure, go into the machine and do all the necessary thing, which is in our lingo is bootstrapping. Kitchen actually does that, and it basically does it through SSH. And again, it's by interacting with the provisioner and so on. But yeah, it does that underlying it. Any other question? What about Windows? With Windows, you can use WinRM, and Kitchen can do that as well. Yeah. Okay. Everybody's simple. All you need to do is go to Kitchen YAML and replace the name so that it has appropriate tag. The rest of the Kitchen here is quite similar to what I've described. There's a little bit of more, I think, more attributes, more information. Such as here I'm going to use Red Hat. What kind of username and SSH key ID? What are the AMI that we're going to create, and so on. So we're in this scenario, we're only going to create one platform, one scenario. Yeah. That's it. And save it. And then make sure you are in that web server directory. You have that Kitchen YAML. And type Kitchen create. You are in my account, yes. You are already in my account, except that now you're gonna, when you're creating it, you're going to use this credentials, the username, to log into it.
Where is the username?
If you scroll down, there you go, platforms.
Oh, this username.
That's the username and password that you're going to use for the new instance. But you're already in my account, and you have all the roles necessary. You good? Okay. If you are successful, you should see some output. And the real telltale sign is SSH is established. So you created the instance and you were able to SSH into it. The Kitchen also, do you have a question? Chef is the bigger universe. It's a Chef basically as a configuration management. Chef has, basically it's cookbooks. You have to write cookbooks to do your automations. You need to store it in like a Chef server. And here what we are doing is having the utility to test that cookbooks on specific platforms. Right? In other words, here the test kitchen is doing the automation, specific automation scenario on specific platform.
It has the scenario part as well, because Chef also has a scenario part by specifying cookbooks.
Yes, that cookbook is your scenario, your automation scenario. The automation that you want to apply to, to your machines, to your servers, how you want to configure that. So I guess in other words, when you're writing with Chef, the focus is more writing the cookbooks, writing the automations. In Test Kitchen, the focus is in testing that automation you just created. But in order to test that, you need to provide an environment for it. You need to check the output of that. That's what Test Kitchen is providing for you.
That's why we have a verifier.
That's why you have a verifier. That's why you have the Test Kitchen will take your cookbook and apply it. So it's your helper in essence, right? Okay. Just back to the kitchen. How many were able to create? Good. If you go back to your code, you will see, sorry, this is not the code. Kitchen also creates a state file. So you see that there's a .kitchen directory. It's just get created. It has logs, and it has a YAML file. So if you go look at the YAML file, it will tell you the server ID and the host name that it just got created. So it's kind of handy. All of this information is handy, tells you the log file, what happened, and which machine got created. All right? Yes? Sorry? What is the... Oh, because you have not... Yeah. Which directory are you in? So you can just do a code. Close that one first. Close that one. Yeah, close it. There you go. Code. Space. Wait. I haven't. Close it. Close it. Yeah, yeah.
Oh, still need to type.
Yeah. You are in the web server. Code dot.
Different.
No, I just easier. This is C. Yeah.
Wrong directory.
Yeah, wrong. You were just wrong directory. Yeah. No, no, no. Everything's correct. It's just wrong directory. Now you're pointing at the right directory. Okay, let's move on. So we have successfully created an instance. We've done this configuration file. So if you do now if you do a kitchen list, well, if you've done it before, you will see something like this where it says not created, but you should see something slightly different. So kitchen list basically listing all your matrix, all your possible scenarios and the suites combined. Yeah? One more thing about kitchen. It will take, so here is the combination of the platforms, the suites and the scenario. So WS1 is the suite name, the scenario name, and Red Hat 7.5 is the platform. You can specify the specific combination. If you don't specify anything, it will basically do everything for you. So you can end up with, multiple scenarios, combination, permutations. You can also use a regular expression. So WS1 star, or I want to create only Red Hat. Yeah. So it has fuzzy matching capability. All right. It is written in Ruby. Oh, okay, yeah. A lot of the underlying chef code is written in Ruby. Yeah. Are you a Ruby programmer? You do? Okay. Oh, that's awesome. Okay, that's awesome. It's actually a pretty neat language. I kind of like growing to like it. I mean, there's a lot of Python programmer out there. It's quite popular. Oh yeah, TDD for the, okay? Yeah. Good. Good, good. All right, we got a lot of catch up. So this is, again, the state file that I've shown you. Now we want to, you just have a bare machine, virtual machine, nothing, just OS right now. So we want to run that scenario. We call it converging, right? And the converging is, in our senses, we're converging a cookbook. The cookbook is very simple. It is getting a package and copying a file, which is the index HTML, would become a content of that, and then starting the service. So everything in Chef is basically, we do it declaratively. We use, instead of imperative, like instead of specifying the steps to do your configurations, we're specifying the end results, the desired state, and with the help of these resources. So packages, files, and services are basically Chef resources that help in automation. Okay? So let's converge. And converge, simply apply that cookbook or that automation scenario. Go back to your command line and do a kitchen converge. You can leave out the WS1, you can specify WS1, you can specify the full name WS1 Red Hat 7.5, up to you. Since you can only create one scenario. In this case, I'll restrict you to one scenario. Okay? Give you some time to do that. So if I go back. I can just do kitchen converge. Anybody need a little bit of help? How are you? Cool. I like your display, very sharp. Easy, right, for you? Yeah. Any questions?
Yeah, we have a lot of questions maybe after that.
Maybe. Or maybe now, one of them.
No, actually, so in Puppet they called us the abstraction layer, right?
Okay.
Yeah, the resource abstraction layer.
Sure.
Basically, like everything is a resource.
Yes.
But what is like what's the way like you already said that imperative statement you need to give it in the kitchen cookbook, and then the chef will implement that, take care of the implementation on the target node, right?
Yes.
So what is the way like it will do that? So it's a Ruby code like in the technical flow. What is the way like a chef enforce the state in the target state?
So basically what happens, the key here is that in the target machine,
Right.
there'll be Chef client running.
So you will also have a
Yeah. So part of your converging is actually installing Chef client,
Okay.
and that will install the cookbook.
So will
And
you-
I'm sorry, yeah, install the cookbook and run the cookbook.
So where does this takes the packages from?
It takes it from the internet.
From internet.
Yeah. But
So what-
if you are air gapped, there's a way for you to specify it from your
Manually, like-
your own repository inside your organization. Yeah.
Yeah. So the mainly the chef is like maybe like you want to discuss some after that I can
Sure.
discuss with you.
Yeah. But good questions though. Any questions? Good.
I have a
Yeah.
question. So in this provisioner step, when you type kitchen converge, right? It is actually installing Chef on it and applying some configurations, or just doing the installing Chef part?
Okay, I'll explain to you what. I guess you have the same kind of question as you want to know what's actually happening underneath. Is that correct? Like how does it do the automation? Good. Okay, so I guess we can see it from here. So there's there's a question, right? It's easy to understand that you have a machine with the kitchen create. But then what happened during the converge actually, right? How does the kitchen actually do the configurations? What is the secret there? What are the underlying steps? So if you look at your output with the kitchen converge, there are a number of things that are happening. The key here is the chef client is the one that's responsible for running the cookbook. Okay? So then we need to install, or the kitchen needs to install chef client on that machine. You create a new machine, right? The kitchen needs to go in, SSH into it with all the username and with all the credentials that you specify, and then it will install the chef client. So you can see that installing chef client. Yeah, well, with Ansible will be slightly different. So Ansible will probably just SSH into it, and then they use Playbook, for example, right? So here we are going to the machine and then installing the chef client, which is needed to run the cookbook. And then it will, after successfully installing client, it will take that cookbook from your web server directory, right? It will take that cookbooks, give it to this node that you just created. After that, the chef client say like, okay, now I know how, I'm running. Now I know you give me a cookbook. I know how to run it. I know how to configure this machine. And that's when the chef client starts executing. That's why it says converging. Okay? And then the chef client says, well, I'm done. And I relinquish the control back to you. So that's what happened underneath. Is that clear or? Yeah, exactly. So it takes the provisioner, it knows you're going to use chef, and under the suites, you tell it which cookbook that you want, right? Any other question? Oh. All right. So you've already converged a scenario, a cookbook. How do you test it now? Well, that will be easy. I gave you the answer before. But seriously, if you don't have a kitchen verify, how would you test this? You would log into the machine, right? And this is a website. I can go to, remember that the kitchen has a state file, and it tells you the host name and everything that it created. So you just copy and paste that to your browser. That's it. Then you can see that your newly created machine already has a package with the index HTML and services up and running. And you mentioned you log into it. So you can do that with the kitchen. You can do kitchen login. Yeah. Sorry. To the machine that you created using Kitchen Create. And I'm just going to exit from there. And obviously, once you log in, you can do a lot of manual things. Everybody's good? Okay. Okay. Testing. So we talk about testings. You can log into it. You can open up a browser. You can examine. But if you want to automate it, what are the things that you can think of to? Okay, like for example, like how do you? What are the things that? Get the URL. Very good. That's more like, to me, is integration test, but that's fine. Like, you know, it's a. But what else? I think that's the ultimate test, in fact, right? You want to do a wget, and you want to do curl, or basically you want to be able to go into that website and see if the content is what you expected. There you go. Either 200 or the content, or you know, or parts of it. But what else other than that? Config file. We already said that we are installing a HTTPD package, right? What are those config files? If it's installed correctly.
For example, like the site must be accessible.
Yep. Exactly. Yeah. So one way you can tell is by looking at the settings, the config file of that website. What are the key config files? For example, if it's Apache, apache.config or something like that. Or Nginx, it will be different things. So those are the key, like the signatures that you want, a file or directory, a presence of that, or even the content of the file will tell you have configured it correctly. Okay. What else? Port. There you go. Port. In this case, simple port 80, right? Or maybe in your test environment you configure it to 8080. So you check whether that's up and running. So yeah, essentially, I think you look into your steps, your resources, you install a package, you enable a service, you put a content and so on. All of those you can check, right? And that's what we can do to automate. We have the automation language with inspect. Very simple. HTTPD should be installed. Port 80 should be running, should be open, or should be listening.
What language is this?
It's inspect. Chef inspect. So we use our own. Remember that in the verifier section, we call inspect. Yeah. So we are doing the smoke test or the integration test using inspect. This is our descriptive language again. Yeah. Obviously, you can do other things. There are other language supported. Yeah.
There's a section where you mentioned we can use like a shell script to test things.
Yeah, I'm not sure if the shell script can go into the verifier section, but certainly, you know, in the creation, the scenario, and the creation of the machines, you can do that. I have to check for the verifier. Again, the same thing. This is similar to what you just said. Check a file. Is a file in that right directory, even with the right content? And lastly, this is the integration test. I can do a curl, and I should be able to compare the output with a certain string or certain expression. Yeah. So before you do kitchen verify, you can see this. You can see that inspect files again by going into this. You will see that under tests integration, default test RB. That's what it looks like. All under one Ruby file, RB file. Okay, so just run your So the last step that you need to do is just do a kitchen verify. That's the output of that. So 4 tests all pass and gives you the final statistics. Okay, so I think we should be wrapping up pretty soon. Anybody have any problem, by the way? I think once you do a converge, you have the results. This is just final steps on the verification. Okay. All right. So a bit of troubleshooting tip. We did talk about kitchen login. You can do manual login to it. If things go wrong, you can do a kitchen diagnose. What it does is it will just print a bunch of information on, what on the drivers, on the provisioners, what are the information it used in all of these things. So it's just basically dump a comprehensive information so that you can you don't have to take any guessing on what's actually the data that's using by kitchen and all the plugins underneath. Another tip, yes?
Is it possible to dump the node object?
The node object. What node object you referring to? Are you talking about chef node object?
Yeah, all the attributes.
I don't think that's available inside the kitchen, but I have to look into the full kitchen diagnose. I don't think it is. Yeah. Okay. Another troubleshooting tip, sometimes when you do kitchen create or kitchen converge, things go wrong, right? And because sometimes kitchen rely on the state information, it's better to delete that state information, start from fresh. So I've seen this a lot, especially when you do the first thing, when you do create, and it takes a long time, your SSH key is not correct, they cannot log into it, or something, anything that you think that you want to start all over, just erase that state information and start all over. Okay? And that's basically the whole kitchen directory. One thing, the command, if you do command, say like kitchen verify, just kitchen verify, it will do create, converge, and verify for you. Handy. And I mentioned about whether you can use the instance, the regular expressions, or you can use the word all. There's another keyword also called kitchen test, which is a little bit more than verify. It will make sure that everything destroyed, and then it will create, converge, verify, and then destroy the things again. So now you can see in the kind of like the power of kitchen create, right? The multiplications or the permutations of the suites and scenarios, and how you can create things and verify things very quickly. So there's just destroy, everything has a destroy, can do a destroy after it. One thing I want to make sure before you leave, and if you don't need the instance anymore, please destroy it. Yes, AWS is going to be, smiling if we leave it too long. Because each of you actually has a workstation, and each of you actually spinning up an instance. So if you don't need that instance, we'll just destroy that. But if you need it, and you want to talk to me about some things, we can talk about it after, or ask me questions. Yeah. Now, just some of the use cases. The use cases, simple, running on multi-platform, which is what I've been talking about, running in different scenarios on different platforms. Another use case is OS upgrade. I've seen this quite a bit. In fact, I caught like a configuration, an old configuration scenario, which before it was supported on CentOS, but then once I gave it a new platform, it stops working on a new platform. So here, where you have this scenario on multiple or on a newer OS, right? Another use case would be an upgrade. So it can be upgrade of the OS, like what we saw before, or the upgrade of the suites, the upgrade of the scenario. Maybe you have underneath that you have different image and different application server or different things runtime with the OS. And lastly, you can also create a different image of the same OS with slightly different configuration and apply the same suite or the same scenario. Okay, see where that breaks. Does it work in the old configuration, old platform? Does it give you the new behavior, the same behavior on the new platform? So that's basically what Kitchen is for. I guess with that, I'm ending this session. If you have any questions. If not, here are some of the resources that you can visit that you can see elaborate more. So there's a kitchen homepage. There's an excellent talk on YouTube on a kitchen, test kitchen. So just search for kitchen chef conference. So chef has a chef conference that happens every year. All of this content available on YouTube. In terms of the tooling that we work, obviously, in terms of corporate, I see a lot of corporate are using VMware. So VRA, VRO, Kitchen does have integration with this tooling. So we'll, in terms of creation of the machines, we're just going to hand it off to the VMware specific tool. And if you have EC2, which we just saw, or Kitchen Docker in terms of containers. Okay. I guess that's all I have for you tonight.